This video is going to talk about some special triangles that we use quite a bit in our study of trigonometry. We're going to start with a 45, 45, 90 triangle. So if you were to think about what that would look like, because it is 45, 45, 90, if you go back to geometry, you also know that's going to be isosceles. Okay, so if we have 45 degrees right here, that means this is 45 degrees, this is 90 degrees. Because these two angles are the same, that means these two legs have to be the same. We get to pick what those legs are. So I'm going to say that this is a side length of 1 and this is a side length of 1. You can make them whatever you want, 2 and 2, 3 and 3, 0.7, 0.7. It doesn't matter so much. Remember that similar triangles will all have the same trig ratios. But using side lengths of 1 and 1 is convenient to start. And then if we need to figure out the hypotenuse, remember we'll just kind of call that x right now. Remember that x squared would equal 1 squared plus 1 squared. Move this up on my iPad a second. So really, x squared is going to end up equaling 2, which means x is the square root of 2. Okay, so because I picked the side lengths, the leg lengths of 1, now I know this has to be square root of 2. And then again, a gentle reminder, it doesn't matter what I picked for these two legs, as long as they're the same, because it's a 45, 45, 90 triangle. If they had been the same, but maybe bigger, that means this would have changed with it, but their ratios are still the same. So when they're asking for the 6 trig functions up here, this triangle will work just as well as any other triangle that fits a 45, 45, 90 constraints. The ratios end up being the same. So I can use this triangle to now talk about what is sine and cosine and tangent, etc. of all of these, of this 45 degree angle. Okay, so I want to know what is sine of 45 degrees. If I look at my triangle, opposite is 1, hypotenuse is 2. And that's pretty good. I'm really okay if you use that. But do remember that we often do not like square roots in the denominator. And so an easy way to get rid of that is just to multiply by the idea that was in the denominator, multiply by that on the top and the bottom. This idea, square root of 2 over square root of 2, is 1. I'm not changing the fraction. I'm not changing the ratio of it. I'm just making it a little bit easier to use. So when I do this, I multiply the tops together. 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is square root of 4, which we hopefully remember just reduces to the number 2. Okay, cosine of 45 degrees. Okay, from 45 degrees, adjacent is 1 over hypotenuse square root of 2. So again, I'm okay if you use that fraction for the most part, but you want to realize that's the same thing as square root of 2 over the number 2. Tangent of 45 degrees. From here, that's opposite over adjacent, so 1 over 1, which is just 1. So far, not so bad. And then we'll go with the reciprocal functions for each one. So the reciprocal of sine was cosecant. Okay, cosecant of 45 degrees. Well, if sine was 1, opposite over hypotenuse, 1 over root 2, that means that this will be root 2 over 1, or just root 2. Secant of 45 degrees. That's the reciprocal of cosine. It works the same way. So adjacent over hypotenuse, that was 1 over root 2. This one will also be square root of 2 over 1, or square root of 2. And then cotangent of 40, well, we got our little friendly reminder up there. I'll just wait for this to pass here a second. There we go. Hopefully your video is showing up something in there. Cotangent of 45 degrees would be, tangent is opposite over adjacent, so this will be adjacent over opposite. That's also 1 over 1, or just 1. So there's a lot of nice simple things about this particular angle. You know, we see a lot of similarities, obviously, in some of the trig ratios, but it's also just an angle that we use quite a bit. and that we use to maybe show understanding of these different properties. I think I'm going to stop right there and pick up the next triangle in the next video.